Good morning. Last topic before we move on to polynomials. So we're going to end our introduction to functions today. We look at inverse functions. So we need to define what we mean by a one-to-one function. Definition of a function. Right. Every element of the domain maps to exactly one element in the range. Right, so you can't have something in the domain go to more than one object. But it never said anything about an element in the range having more than one element in the domain going to it. Right, for example, x squared. Positive 2 and negative 2 both go to 4. This is where the idea of one-to-one comes in. One-to-one functions have the added restriction that each element in the range has one and only one element in the domain that corresponds to it. So x squared wouldn't be one-to-one. The identity function is, though. F of x equals x. That is one-to-one. Two ways to verify one-to-one. Algebraically. This is the algebraic definition. For every x1 and x2 in the domain of the function f, if f of x1 equals f of x2, then x1 has to equal x2. The other method is graphically. So to test for a function, we have the vertical line test, right? Well, to test for one-to-one, you have the horizontal line test. And the horizontal line test is identical, except it's a horizontal line instead of a vertical line. Right, you draw a horizontal line on the graph. If it intersects more than once, it is not one-to-one. There's also the idea of what's called onto functions. Right, a function is onto if every element in the codomain has an element in the domain that goes to it. So the codomain equals the range. For the most part, every function we study in this course will be onto. And there are other names for these. So you may hear me refer to a one-to-one function as an injection. Onto functions are also called surjections. For any one-to-one function, y equals f of x, a function, it's called g of x for now, is an inverse function of f if g of y equals x. Right. Also written, g of f of x equals x for every x in the domain of f, and f of g of x equals x for every x in the domain of g. Obviously, that is the notation f to the minus 1 power to represent inverse of f, and is read as f inverse. And with this notation, it's important to note the distinction. That it is not reciprocal of f. It is inverse of f. So let f have domain D, range R. F inverse has domain R and range D. So the roles of the domain and range switch for the inverse. F of x has an inverse if and only if it is 1-to-1. What this means is every 1-to-1 function has an inverse. And if f has an inverse, it's 1-to-1. So a great way to test if a function even has an inverse is to check to see if it's 1-to-1. If it's not 1-to-1, it has no inverse, so there's no point in trying to find it. That means the function x squared does not have an inverse. It's not 1-to-1. So trying to visualize what an inverse function really does, go back to the mapping notation. Let's make that a little bit larger. We have a set A, we have a set B. It's going to use 1 point in each. What F does is it sends F to Y or X to Y. So it tells you what output you get with the input. What F inverse does is tell you what the input was to get the output. So it sends Y to X. Let's see how well this works. I still need to do that. Let's just put that there for now. That's fine. Yeah, that's not coming up too well. Let's fix it. Right, if G is an inverse of F, then F is an inverse for G. So we'll typically just say that F and G are inverses of each other. If F inverse is the inverse of F, then the inverse of F inverse is F. Right, so you inverse and inverse, you get the original function. That should be pretty obvious. If g and h are both inverses of a function f, then g equals h. This says that the inverse is unique. There's only one. So if a function has an inverse, it only has one inverse. So show that the functions are inverses. It means there are two things we have to show. F of g is x, and g of f is x. So start with f of g. It means that f of g is f of x plus 3 all over 2. Replace x plus 3 over 2 in x in the definition of f, right? So every c in x and f, replace with x plus 3 over 2. 2 times x plus 3 over 2. Right? It's just x plus 3, isn't it? And x plus 3 minus 3 would just be x, wouldn't it? Now check g of f. In the definition of g, replace x with 2x minus 3. 2x minus 3 plus 3. Just 2x. And then 2 over 2 is 1. We're left with x. Both cases, we got x. That means that f and g are inverses. Notice the wording here. Show that. This means the statement is true. Why are you popping up? No, I don't want to do that. Upload fail. Yeah, okay, whatever. Go away. So I'm telling you that they're inverses. It's your job to prove it. Which means if you don't get them to be inverses, you did something wrong. Those are the best kinds of questions because you already know what the answer is. The worst kinds are if I say, are they inverses? Because then you have no idea if you did it right or wrong. Here, at least you know. So show that the function's x squared plus 3 for x greater than or equal to 0, and g of x equals square root of x minus 3 for x greater than or equal to 3 are inverses. First thing to notice, Chanel, let's just pretend that's not there. I wouldn't be able to say show in this case because they wouldn't be. F of x is not 1-to-1, which means it doesn't have an inverse. However, with that now, it is 1-to-1. Right? It's only not 1-to-1 because when you square a negative, you get the same thing as if you square its positive. If I eliminate all the negative numbers, now it's 1-to-1. So in general, you can make any function 1-to-1 by restricting its domain. That concept will be important. And so first find f of g of x. All right, clearly this is defined because x is greater than or equal to 3. So take the square root of x minus 3, square it, then add 3. When you square that square root, you just get x minus 3, right? Now you have a negative 3 plus 3. That's just 0. And you're left with x. Now for g of f. G of x squared plus 3. Take 3 from x squared plus 3, then take its square root. 3 minus 3 is going to leave us with just x squared. So we have the square root of x squared. And the square root of x squared is the absolute value of x. However, the domain for f says that x is non-negative. And the definition for absolute value is piecewise. So the absolute value of x will give you x as long as x is non-negative, or negative x if x is negative. And which piece has the or equals part doesn't matter. You can flip it for your convenience. Right? So I could rewrite it as x when x is greater than 0, negative x when x is less than or equal to 0. Just for whatever suits my needs at the time. With that, that means that this absolute value of x is just x. And that's because x is greater than or equal to 0. That's why that restriction was important. And if that restriction wasn't there, we'd have to leave it as absolute value of x, which is 2 functions. That means f and g are inverses. Right, and that'd be a great way if you don't recognize a function not being one-to-one. If you get something like this in one of your compositions where you have more than one possible function, then you know, oh, I guess it wasn't one-to-one. Right, in this case, f wasn't one-to-one. If f of g gave me more than one possible function, then g wouldn't be one-to-one. So square root of 4 minus x less than or equal to 4, and 4 minus x squared for x less than or equal to 0. Show that these are inverses. F of g, f of 4 minus x squared. Oops, that's a typo. So let me fix that. That should have been f of x is negative. Now that messes all that up. Was it there? That works. Now let's fix that. 4 minus 4, 0. We're left with minus negative x squared, which is just positive x squared. Again, square root of x squared, absolute value of x, negative square root of x squared, negative absolute of x is what we have. Refer back to the definition of absolute value of x. And what I said is I can put the or equals part in either of the two inequalities. So in this case, I'm going to switch it to the second part. Because we know that x is less than or equal to 0 for g. So we can write that as negative x, which is just x, because x is less than or equal to 0. Yay. G of f. G of negative root 4 minus x. Square of the negative square root just gives you 4 minus x. Now we have 4 minus 4, which is 0. And we get minus negative x, which is just positive x. And we find that f and g are inverses. Okay. So we're going to show that this function is 1-to-1, and then we're going to find its inverse. Even if I get rid of the show it's 1-to-1 part, and I just say find the inverse of this function, first thing you might want to do is check that it's 1-to-1. Because if it's not, then it doesn't have an inverse. And that's what you would state, has no inverse. And so again, you don't really want to spend time trying to find an inverse that doesn't exist. This one is fairly obvious. That's 1-to-1. Which makes it the perfect practice for proving. So our claim is that the function 4x minus 1 is 1-to-1. Now we get to do the fun part. Do I have any math majors? Oh, that makes me sad. Because if you are a math major, you're going to get sick of that word real quick. Proof. Never proving it. Curse word for a lot of math students. Remember what it means to be one-to-one. For every single x1 and x2 in the domain of f, it is necessary for x1 to equal f2 for f of x1 to equal f of x2. And this is where the math language is really going to become apparent. Element of or in. So I'm saying suppose that x1 and x2 are in our domain of f such that this statement is true. So such that f of x1 equals f of x2. What does that mean? Well, that means 4x1 minus 1 has to equal 4x2 minus 1. What we are now going to do is show that we get x1 equals x2. Solve it. Add 1 to both sides. Yeah, 4x1 equals 4x2. But you can now multiply both sides by a quarter, which means x1 has to equal x2. Therefore, we can conclude that this function, f of x equals 4x minus 1, is indeed one-to-one. Settings. Now to find its inverse. This is where this visualization of the inverse comes in handy. Right? Remember what the inverse does. It tells you the input for a specific output. So what we're going to do is say, let y just be some specific value in the range. That means that y equals 4x minus 1 for some x in your domain of f. Our goal is to find that x. And we know that there's only one x that satisfies that, because we just proved it's 1-to-1. So not only do we know such an x exists, we know there's only one x that exists that satisfies that condition. Well, you'd add 1 to both sides. Then you'd multiply both sides by a quarter. So that specific input is y plus 1 over 4. All right. What that tells us is I can now give you an output value. So there's 4x minus 1. That's your function. I go, okay. What value maps to 6? 6 plus 1 over 4. F of 7/4 is 6. What value maps to 100? Right, 101 over 4. What value maps to 99? 25. That's what that's telling us. Now you can just flip the roles of y and x. Because remember, they're just dummy variables. X plus 1 over 4 is the inverse function. It is customary to always write it in terms of the independent variable of the original function. So if that was f of y, we'd say f inverse of y. Right? If there's f of w, it'd be f inverse of w. That's just the convention. So that would be our inverse. And you can always verify that by doing f of f inverse and make sure you get x. By the way, it shouldn't be difficult to prove that if f of g equals x, then g of f is also going to automatically equal x. That shouldn't be difficult to prove. So when you're trying to verify that you have the right inverse, you just have to do one order. Just do f of f inverse or f inverse of f, just do one of them. If you get x on one of them, you're guaranteed to get x for both, so you're done. Okay, there's that one. So again, show that the given function is 1-to-1, and then find its inverse. And once again, our claim is that our function is 1-to-1. We're now going to prove it. So let's move these up to give me a little bit more room. In this case, I can actually just write this. Be in actually, it'd be easier to write that. I was going to say all real numbers, but it's not. Implied that x can't be -3. Right, so x1, x2 can't be -3. Such that f of x1 and f of x2 are the same. Right, again, what is that saying? That's saying that x1 and x2 are two elements that map to the same output. Our goal is to show that they're actually the same. So another way you could see it is we want to show that x1 equals x2. Or it is sufficient to show that x1 equals x2, something along those lines. And just another way of tackling the proof. This way I don't have to reach my conclusion at the end, because I've now already told you what I'm trying to do. Since f of x1 equals f of x2, that means 2 over x1 plus 3 has to equal 2 over x2 plus 3. There are two ways to go about this. First way is the standard way. You see a fraction equals a fraction, and you want to solve for x. You typically cross multiply. So you can cross multiply in this case. Or you can look at the numerators and go, well, the numerators are equal. That means there's only one possible way for those two fractions to be the same, and that's for the denominators to also equal. So right away, I can conclude x1 plus 3 and x2 plus 3 have to be the same, which is what you would get if you cross multiply with an additional step.
If you cross multiply, you just do 2 times x plus 3. You leave it like that? Like 2 times x plus 3 equals 2 times x plus 3, or do you have to completely finish it?
You don't have to expand them out.
Okay.
Because then, at that point, you can then go multiply both sides by 1/2.
Yeah.
And that gets rid of the 2's, which leaves you to this step.
Yeah. Okay.
Right, that would be the only additional step you have to take, is to multiply both sides by 1/2.
Okay.
And then from there, it's pretty clear to see that x1 has to equal x2. And I can now stop, because I already stated that that's what we were trying to do. Oh, that's not what I wanted. Oh dear. I think I'm supposed to be at 91% zoom. Yeah, there we go. So we've shown it's 1 to 1. Now we have to find the inverse. So let y be an element in the range. Another way of wording what I did before. Let me do it this way. Such that 2 over x plus 3 equals y. Right, then there exists an x in the domain such that 2 over x plus 3 equals y. It says the exact same thing as the previous example. I just worded differently. And then as before, our goal is to find that input, that x. This time we are going to have to cross multiply. Two equals y times x plus 3. Distribute that y through. That means 2 minus 3y has to equal x times y. And that means 2 minus 3y over y equals x. So the inverse function would then be 2 minus 3x over x. I am missing a question. I'll cross that bridge when I get to it. Sure, this is 1 to 1. 4x greater than or equal to 0. And then find its inverse. So what I'm going to do is I'm going to do a variation of this first. We'll say, is the function one to one? Get rid of that. And then if so, find its inverse. And it's probably more likely of what you're going to see on a test or a quiz. So then what you have to do is you have to look at the function and decide, is it 1-to-1 or not? If it is, you have to prove it. If it's not, you have to provide me a counterexample showing that it's not. So our claim, what do we think? X squared minus 9, is that 1-to-1?
No.
So we'd claim that it's not 1-to-1.
Because it's a parabola.
Right? The proof here is actually a counterexample. Which means you'd have to provide me with two different inputs that give you the same output. Well, let's look at -3 and +3. F of -3 is 0, f of +3 is 0. So what we've done is we've said, oh look, f of x1 and f of x2 are the same. But x1 does not equal x2. Which means it's not 1-to-1. And so I'm done, I don't have to do anything else. Means no inverse exists, so don't have to worry about it. Right, so generally speaking, on questions like this, on questions like this, it is not good enough just to simply say it is 1-to-1 or it's not. You have to support your answer. All right, now the actual question. So the claim is that the function is 1-to-1 for x greater than or equal to 0. So I'm going to say let x1 and x2 be greater than or equal to 0 such that f of x1 equals f of x2. It suffices to show x1 is equal to x2. what we have is x1 squared minus 9 has to equal x2 squared minus 9. Right, another way of writing those, I'm going to add 9 to both sides without the parentheses. Right, we have x1 squared equals x2 squared. This means the absolute value of x1 equals the absolute value of x2. That means that x1 equals x2 because we said that both x1 and x2 are greater than or equal to 0. And so we've now shown that it's 1 to 1. Now to find the inverse. Right? So we say y is some element in the range of f, then there has to exist an x greater than or equal to 0, such that x squared minus 9 is equal to y. Thus, now I'll write it up here. X squared would be y plus 9. Absolute value of x would be y plus square root of y plus 9. Right, square root of both sides. But this means that x has to be square root of y plus 9, since we know that x has to be greater than or equal to 0. That means that f inverse of x is the square root of x plus 9. Right, now for the missing question. Excuse me for a minute. Let's see what happened to it. It's not there. Okay, so And we should be good. Show it this function for the specified domain is 1 to 1 and find its inverse. I'm going to use the shorthand for 1 to 1. Just use the numbers instead of spelling it out. So our claim is that this function is 1 to 1 for x less than or equal to -3. Right? It's never good enough just to claim something. You always have to support your claim. And so let's prove it. Wow, that's true regardless of whether you're in math or not, right? Whenever you make a claim, you always have to support it. And in fact, that's generally the whole point of English 101. A lot of the time is you have to support your opinions in your paper. You thought math was different. I think you do more writing in math than English, to be honest. Yeah, seems weird, doesn't it? Read a math paper. It's a lot worse than an English paper, let me tell you. It's also a lot more dry. It's awful. What's even worse is you generally don't understand anything that's being said in the math paper. You kind of just accept it because the authors clearly know more than you. So we're going to say let x1 and x2 be less than or equal to -3, such that f of x1 equals f of x2. Suffices to show, I really shouldn't make my W's curly. Suffice to show that x1 equals x2. I mean, obviously subtract 4, right? If we now take, well, I have enough room there. I should. If we now take the square root of both sides, this is what we get. Absolute x1 plus 3 has to equal absolute x2 plus 3. This means that negative quantity x1 plus 3 has to equal negative quantity of x2 plus 3. This is because I'm going to write it this way, actually. We have x1 and x2 both being less than or equal to 3, or negative 3, which means x1 plus 3 and x2 plus 3 are less than or equal to 0. Now think back to your definition of absolute value. Since the quantity is less than or equal to 0, the absolute value will spit out the negative of that quantity. Oh dear. I'll just have to finish that proof on a new slide. Multiply both sides by -1. And subtract 3. So we get x1 is equal to x2 as desired. Now to find the inverse, let y be an element in the range of f. Then we know that there has to be an x in our domain satisfying that relation. Solve for x. Right, x plus 3 squared has to be y minus 4. Which means that the absolute value of x plus 3 has to be the square root of y plus 4. I'm actually just gonna write it this way. Means x plus 3 has to be negative root y plus 4. Right? Again, because x being less than or equal to negative 3 implies that x plus 3 is less than or equal to 0. And this implies x is negative 3 minus the square root of y plus 4. Why did I replace minus with plus and all of that? I have no idea. That was supposed to be y minus 4, not y plus 4. That's an easy enough fix, at least. Look, I did it in my notes too, which is funny. And now, just for fun, if we go back to here, what is the domain of our inverse? So what's the range of f? Everything, right? So what's the domain of the inverse? Everything. Which means the range of the inverse is also everything. Because the domain of f is everything. Domain of f here, everything but negative 3, which means the range of f inverse is everything but negative 3. What is the range of f? Get you started. There's only one number that you can't get out of 2 over x plus 3.
I was going to say 0, but it's not 0. Oh,
You cannot get 0 from that. So the range would be everything but 0, which you can confirm by finding the domain of f inverse, which is everything but 0. We already know the domain of f here. They told us, which means the range of f inverse would be greater than or equal to 0, all non-negatives. But what about the range? So what is the range of f?
So all real numbers.
Is it? What is it?
Isn't it the same all non-negatives?
I can easily disprove that. Let x be 0. What's f?
No.
Negative 9. It's 0 minus 9.
Okay.
So you can get negatives.
Wow.
But wait, what happens as x gets larger? Take a number larger than 0 and subtract 9 from it. Isn't it larger than negative 9?
Mm-hmm.
That's everything greater than or equal to negative 9. That's the range. Even if x wasn't greater than or equal to 0, it would still be everything larger, greater than or equal to negative 9. Because all the negatives, when squared, give you the positive values.
And then like if you put it on a graph or something, like you would see.
It's a parabola. Yeah, the vertex of the parabola is at negative 9 on the y-axis. That means the domain of f inverse is greater than or equal to negative 9, which you can easily confirm by looking at it. This one's an interesting one. Domain of f is less than or equal to negative 3. That means that's what your range of f inverse is, right? Range of f. And try to do it without looking at f inverse. So you have x plus 3 quantities squared, which means that's always going to be non-negative, right? Because you square a negative number, it still gives you positive. So what's the smallest possible value x plus 3 squared can be?
0.
0. What's 4 plus 0?
4.
What happens when you add numbers larger than 0 to 4? Goes up, right? That means your smallest value for f is 4. So the range is greater than or equal to 4. Which again, you can easily confirm by looking at f inverse and finding its domain greater than or equal to 4. Yeah, that's right. Okay. First quiz is now available. You have 90 minutes to complete it. Has to be done in one sitting. Once you start it, you can't leave and come back to it. It's worth 50 points. Once you hit start attempt, oh, that's nice. At least they give you a warning. The timer starts. Now, I've never actually seen the quiz from the student view before on the new Blackboard, so this will be new for everyone. All right, so this is, okay, yep, so that is, of course, the instructions. Oh, that's actually annoying. They don't give you a timer on here. That sucks. The old Blackboard did.
I think it's
at the very top, 90 minutes from you. So it's like every minute, like click down.
Oh, up here.
Yeah.
That's still annoying. They should still give you the seconds.
Yeah.
The old Blackboard did. Okay, good. They actually do consider this 12 questions and not this text as a question. Sometimes they do. Right. So there is a mixture. Multiple choice, fill in the blank, numeric response, and file uploads, which, again, the new Blackboard doesn't actually have that category. So I have to make it an essay. And then you have to attach the file within the actual text box. Why they took that question type away, I will never understand, but they did. I'm not a fan of the new Blackboard. Really don't like it. For your file uploads, so the essay questions, you'll need to complete your work on loose leaf paper in either pencil or black ink. I won't accept anything else. Make sure, you can actually ignore the clearly label the problem part, and I'll explain that later. Make sure that this work is legible and neat. Included in that is writing large enough so that I can actually see it. If I cannot read or understand your work, I'm not going to grade it. So the file that you upload must contain only the work for that question, which is why you can ignore the clear label. Right, so first essay question, you'll just do your work, upload that file. Another essay question, probably just start a new sheet of paper. It is recommended that you upload your work as a PDF, but you can also upload it as an image. However, I think you're limited to, are you with essays? You might not be. You might be able to upload multiple files, but I only want one. So if it is an image and you have multiple pages, you can't upload it as a single image. Right, because each image is only a page. So you'd have to actually convert it to a PDF. A few ways you can do that. If you have a scanner, that's probably your easiest way. Or just get a free PDF scan app on your phone. I use Adobe Scan. It's the one I like. One I see a lot is Cam Scanner. Right, they can just either save that PDF onto the cloud, because you then have access to it on your laptop, or send it to yourself via email.
How do you do it on here?
You just upload it. I'll show you. I do award partial credit at my discretion on the quote-unquote open-ended questions, so only the ones that require file upload. Multiple choice, numeric response, fill in the blanks, I do not. It'll be automatically graded, and that's the score that you get. So see that's a fill in the blank. Where's a nice file? Oh, look, multiple choice. Okay. Starting off easy.
I like that.
Yeah, here we go. Right, so here's one where you have to upload your file. Just click. And then choose your file. Yeah, why not? Let's just do that from Calc 3. They ask you to do a display main. Yeah, you don't have to change it. And now it's attached. If it's the wrong file, it does let you delete it and re-upload. And again, I think I could upload multiples. It will let me, but I don't want them. For images, you can also just technically do that. The problem with this is that it doesn't actually attach it as a file. That's an image. Or it'll post it as an actual image. I think it will give me the option to download it. No, just expand. So it doesn't even give me an option to download it. So that, again, that's not preferable. If you're going to do an image, probably just do the attachment option. I don't think that's going to, let's see, attachment, pictures. Let's look at screenshots. Yeah. I'll look at this and see what happens. Oh, you've got to be kidding. It's going to do the same thing. That's actually really annoying. What happens if I click? Oh, nope, okay. That's nothing. Oh, that's annoying. So it doesn't matter how you do it, it's still going to upload it as an actual image and not a file I can download. Of course. If you do that, I'll make it work. But be advised that if it's not a supported file type, I won't be able to view it. So again, your best bet is to convert it to a PDF and upload it as a PDF file. All right, this is an example of numerical response. All right, so all you have to do is, I don't know, 0. I don't know if that's right or not. And then move on to the next one. Cool, that's actually nice. You've reached the end, right? So it gives you an option to review your answers. That's nice. Okay, so it's going to show all unanswered, it looks like. When you're done, you just hit submit.
Does it show you? Oh, it doesn't show you the score. Right?
It won't show your total score, but I don't know if I have it set up to show you each question score after you submit. Obviously, the file uploads, the one I have to grade, you won't get that score right away. But you might be able to see the multiple choice ones if you got it right or wrong. The numeric response, those you might be able to see. I either have it set up to do it immediately or after I post grades. And that's nice. So it gives you a little, look, you've submitted it. So download certificate as proof of submission. Yeah, I'd recommend you do that just to be safe. And there's no worse feeling than actually submitting it. And for some reason, I don't get it. So you get a 0. At least then you have proof that you submitted it. So yeah, I would download that and save that somewhere, just in case. So a couple warnings. As I said, once you start it, it has to be finished. It can't be closed. If it closes out, it will not let you back in. So make sure that you take care of your business beforehand, and also make sure that you're going to have a stable internet connection.
And then the computer's charged.
Because if you lose your internet, it will boot you out. And then you can't get back in. Your best bet there would then be to contact me and hope that I get it in time to reset your quiz before it's due. Of course, that means it's a reset, so you lose all of your work. You'd have to start over. So you may want to avoid that. Again, it's not totally unavoidable, but definitely reduce your chances, right? Don't start in the middle of a thunderstorm, because, you know, it's a pretty high chance you're going to lose power. At least a higher chance you're going to lose power in a storm than not storm. So notice when it's due before our next class. So that gives you the rest of today and all day tomorrow to work on it. 90 minutes is more than enough time to finish it with uploading files. Right? It's only 50 points. You have 90 minutes to do it.
So
Even if you figure each point is 1 minute worth of working on the question, that leaves you 40 minutes over.
How do the tests work?
Tests are in class. So we'll worry about that as that gets closer, which is coming up in a couple of weeks. Oh, it does let you view submission. So it doesn't look like it's going to show you the right or wrong right away. So it's set to be after I post the grades. Now we got several things coming up. Quiz, homework, and the first project. All due Wednesday. And then the homework on this stuff, obviously, due in a week. We start polynomial functions. Say Monday? Yeah, so we start polynomial functions on Wednesday. I will see you all on Wednesday.